Dear students, in this class we are going to see about basic link analysis. So actually a link it is a terminology which defines the clear path direction between earth station to satellite as well as satellite to earth. So if you create a link between earth station to satellite, that is called the uplink. Similarly, the same link we want to develop from the satellite to earth station, that is called downlink. And one more thing about this uplink as well as downlink, we can't shoot both uplink as well as downlink, which can't use the same set of frequency, because uplink frequency is somewhat greater than the downlink frequency. But anyhow, if you transmit signal or information from earth station to satellite system or satellite to earth station, there will be a enough distance between these two. The distance in terms of more than 1000 kilometers. So if the satellite is orbiting under the low Earth orbit, so distance may be around 500 kilometer. The same if you measure a distance between satellite to earth station under the geostationary orbit, the distance may belongs to more than 30 to 40,000 kilometer. So why we are talking about distance while you are discussing about the link analysis? Because distance play a major role while you are going for link analysis. So the link analysis is nothing but if you transmit information from the earth station to satellite, so we must know how much amount of power required. So power required in the sense the informations are transmitted from the earth station via transmitter antenna only. So we have to check whether the antenna will able to transmit the enough power level in order to reach the particular satellite, because the distance. Well, while the signal or while the information are transmitted from earth station to satellite, so the path distance, you know, it is very long distance. So if the information reaches to the satellite, we can't shoot the same amount of information received by the satellite receiver. Because in between earth station to satellite, there will be a more number of hurdles there, more number of obstacles are there. When our signal meets or strike upon any obstacles or object between these two, there will be losses will be takes place. So the information is surely getting lost when it's travel along the air medium. Supposed to be medium, it's a free space. So there will be a more number of obstacles are there between earth station to satellite. So finally, we have to think about these parameters, what are the obstacles are there between say earth station to satellite, and these hurdles we have to calculate, these hurdles we have to take into our account regarding the power budget calculation. So and distance, and then only we must know how to or how to design a station antenna, both side, both earth station as well as the satellite system. So while you are looking the satellite link picture itself, it comes to understand the left hand side you can have the transmitted earth station, that is transmitter. So from this earth station will transmit information through the uplink, that is EARP, that is effective isotropic radiator power, that is the antenna capacity. So we have to measure the capacity of the isotropic radiator, whether this radiator will able to generate the required power level in order to reach our information to the receiver. And while the information is transmitted through the medium between earth station to satellite, and we can see so many number of losses are there when it meets any obstacles, or when it travels along the more number of like a troposphere, ionosphere, nanosphere, metosphere. So many number of regions are there in the space, and when the signal passes on one by one layer, obviously there will be some losses will be happens. And apart from that, here you can see there will be another earth station. This earth station also will transmit kind of information to the same satellite, and there will be some chances of there between some interferences. So the interferences happen when the two informations reaches to satellite at a same time. That is called actually co-channel interference. You can see. So here the satellite will send information, sending information to the earth station, as well as the same way there will be a earth station sending information to satellite. So there will be a co-channel interferences takes place. So this is also going to be reduce our signal strength. Apart from the transmission path losses, apart from the medium losses, apart from the interferences, there will be some losses happen even the transmitter side itself. Transmitter, I mean the receiver side itself. So receiver, it is made up of the electronic equipments only. So the equipments, when the equipments are continuously running, continuously working, means obviously there will be some thermal noise will be generated. So due to this thermal noise, it will also will be add upon the noise level, so that the SNR value getting low. So we have to think about these hurdles or these parameters while you want to transmit information from the earth station. The same way, while you are transmitting information from satellite to earth station, so towards downlink directions. So again, there will be some path loss will be takes place, and even though the antenna is available in the earth station, there will be some thermal noise will be takes place, because in the earth station also we are using some amplifier and some oscillator, some circuitry sections are there, and these circuits are continuously working, means there will be some temperature, I mean heat, or in terms of thermal noise will be takes place. So anyhow, in both side, from earth station to satellite as well as satellite to earth, so both uplink as well as downlink, so the complete link analysis will be made up of with the help of these path loss components, as well as channel interferences parameters, as well as what all the noises happen inside the equipment itself. Everything we have to include in order to find the exact power level required to transmit the information from earth station to satellite, similarly satellite to earth station. And you can see whatever so far we have discussed. So here there will be earth station antennas there, and this is the actual beam width generated from the earth station, and finally the width should be reduced. Because when it meets some obstacles like rain or troposphere layers, or there will be some rays coming from the sun or moon, some cosmic rays, and finally the signal get received by the satellite, that will be very low or very minimum level. So in these losses we have to calculate in order to find the power budget level value. And what is necessary, why we want to find the link budget? So actually the link budget is nothing but we have to ensure what is the minimum capacity required to even though signal getting lost. But if you provide some minimum capacity, if the signal having minimum capacity, then from this we can able to recover our original informations. Okay, so how to set the threshold value for being the minimum capacity? So what type of modulation scheme what we are using in the transmitter side, and we have to increase the decoding level gain value, and the bandwidth level, as well as the thermal noise values, everything we have to calculate. And here we have a transmitter and here receiver. So in transmitter itself we are having some losses maybe takes place. So the high power antenna, even though we are using high power antenna, and even though the antenna is available, some transmit losses will be takes. There will be some misconnection between the connectors as well as the adjacent components, or there will be misconnection between cables as well as the parabolic reflector, and maybe some, if there is some gain losses in the antenna itself. So everything happen, even the transmitter side also, and even receiver side. So whatever the noises happen, or whatever the losses available in the transmitter side, the same amount of losses also will be takes place in the receiver side also. And apart from the transmitter as well as receiver, there will be some loss happen because of the medium also. So when the information passes through the medium, there will be a free space loss, and it meets upon some atmosphere layers, some E region, D region, F region. There, because these regions are having consists of some molecules, gases, components. They are try to observe our information. Even when the rain, so a raindrop also, which will create much impact, reducing the signal strength. Because when the signal meets the raindrops, obviously the signal may be absorbed by the rain or getting reflected. So whatever it happens, definitely the signal strength getting reduced. And even though some kind of pointing losses, so pointing losses is nothing but we have to ensure both the transmitter as well as receiver antenna are facing each same direction. So if there is some misalignment takes place between either transmitter side or receiver side, again there will be some losses will be takes place. Okay. So we have to, if you want to design a power budget value, so we have to think about these parameters, losses in the transmitter side as well as receiver side, and even the medium losses. Okay. Thank you, students.